Hello everyone, welcome to Mariner's Point. We are going to discuss MEO Class 4 Electrical Written Numerical Questions. So coming to the question, we have a 15 kilovolt ampere 440 110 volt 50 hertz cycle per second single phase transformer has primary and secondary resistance of 0.12 ohm and 0.0077 ohm. The iron loss of the transformer is given, which is 0.16 kilowatt. We have to calculate the efficiency of transformer on full load in condition of power factor 1. Okay. In the second condition on 80% full load at power factor 0.9, which is in lagging. Okay. The data we have given, you can see on the screen, transformer rating given 50 kilovolt ampere and primary voltage is given how much 440 volt and secondary voltage 110 and frequency 50 hertz. Primary resistance is given, secondary resistance is given, and iron loss. As we know that iron loss in transformer is constant. Value is given in kilowatt, which we have converted into watt. Okay. Now, in the first condition, full load current, you can see now at full load on secondary side, first we will calculate I2. You can see on the screen how I am calculating value of I2. As we know that power is equal to VI. Rating is given, voltage E is given. Then we will easily calculate I2 is equal to rated kilovolt ampere. We will convert into voltage ampere. So multiplying into 1000 and voltage. How it comes? Power in a kilowatt ampere is given. VI, then I is equal to power by V. Power is rated kilovolt ampere into 1000. Okay. So value of I2 is 136.36 ampere. Now we will calculate at primary side. Same formula we will use. Primary voltage is given. Then using formula power is equal to VI. VI is rated. Power is given. And we simply calculated primary side current and secondary side current. Now total copper loss at full load we have to calculate. So copper loss occur in both winding we have to calculate. So total copper loss at full load. First condition we have to calculate full load power factor 1. So copper loss is equal to I square R. You have to remember this. Okay. Iron loss is constant, that is given already, and formula for copper loss is I square R. So for primary coil we can take I1 square R1 plus I2 square R2. It is for secondary and it is for primary. So simply we have already calculated primary current and secondary current. We have to only put the value and we will calculate copper loss occur in both binding. That means primary side and secondary side. So total copper loss at full load we calculated. Now we have to calculate efficiency. So what is the formula of efficiency? Formula of efficiency is output power divided by output power plus loss into 100. This is our efficiency. And total loss, as we know that iron loss plus copper loss we already calculated. Now efficiency formula we know. Now we have to calculate efficiency at full load when power factor is unity, that is 1. Now power output is rating into power factor. Power factor is equal to output power divided by rating. The rating is represented by S. It is simply represented in kilovolt ampere. Okay. So output power we can calculate. How can we calculate output power? Rating into power factor. Using this formula, we can calculate output power. Output power rating into power factor. Okay. Now total loss is equal to iron loss plus copper loss. Now we will apply efficiency formula. We already know efficiency formula. Efficiency output power is 15 and output power plus loss. Loss we have calculated iron loss plus copper loss. Copper loss formula we already know. Iron loss is given. Then using this formula we can get efficiency. How much? 97.13%. So first we have to remember efficiency. Power output divided by power output plus total loss into 100. Output power is equal to rating into power factor. Total loss is equal to total loss is iron loss plus copper loss. Iron loss is given which is constant. Okay. So copper loss in primary binding plus secondary binding. Primary binding copper loss formula is I square R and secondary I square R. Then this is copper loss, total copper loss. Summation of primary plus secondary, that is total copper loss. So thus we have calculated efficiency in the condition of full load at unity power factor. Okay. Now next 80% full load at 0.9 power factor lagging. Okay. Now load is equal to 0.8, it is given, into full load. How much full load? Full load is given 0.8 into 15 kilovolt ampere. Then we will get 12 kilovolt ampere. It is our load. So we have calculated load. How much? 12 kilovolt ampere. Now we have to calculate output power. How we calculate output power? Formula of output power is rating into power factor. Rating how much? At condition of 84% full load is 12 into 0.9. Now 10.8 kilowatt is our output power. Now we have to calculate copper loss. Formula for copper loss is as we know that I square R, and at the condition of full load we have calculated how much? In the condition of full load we have calculated PCU at full load. In the above question we have calculated. So at 80% full load copper loss will be 0.8 square into copper loss at condition of full load. Then using this we will get copper loss 0.181 kilowatt and the iron loss will be same. It will be constant. So total loss we will get iron loss plus copper loss. Copper loss vary with the square of load current. That's why we use this formula here. You should know this. Copper loss is a square of vary with the square of load current. That's why this is a square. We will already know at full load condition and load is varying 80%. It vary with the square. So that's why we use this formula. Okay. Now we will apply formula efficiency formula. Output power we have calculated. How we calculated? Output power is equal to rating into power factor, and this is our loss. Loss we have calculated. How we loss calculated? Iron loss plus copper loss. Or iron loss will be always constant. It is given in the question. We have to calculate copper loss, and copper loss vary with the square of load. So now 80% load. Then we have already calculated at full load condition, that is PCUFL. Then in this condition copper loss will be this much. Okay. Then efficiency in the second condition will be 96.93%.